We are about to kick off our second session in this room, which is titled New Features in MongoDB 6.0 and How to Get More Out of Aggregation with Stefan Constantinides.
Yeah.
Stefan is a champion of digital transformations. He brings over 20 years of technical solution selling experience to the table by being a virtual bridge between engineering, technology, and the business benefits of the solution provided. Stefan specializes in aligning all departments of the prospective customer to recognize the value provided. Stefan has a programming background with 10 years of experience in C, C++, and Java prior to being a solutions architect. So please join me in giving a warm welcome to Stefan.
Thank you. Thank you, sir. Okay, good morning, everybody. I'm Stefan Constantinides, as you just kind of heard. So we want to walk through what's new features in 6.0 and aggregations. So let's jump right into it. So quick overview of what we want to talk about, what's new in 6, and then we'll frame it down to what's new in aggregations. We're going to go through some examples, and then a quick summary and some questions. So hopefully that'll be good for everyone. So just very quickly, I wanted to kind of summarize or go over some of the new features in 6. Right, so we've got this cluster-to-cluster. Complementary, you've heard a lot of what Andrew said, so I'm not going to spend too much time on that. Queryable encryption. What I am going to spend time on is the new query framework. So specifically with aggregations and how the new query framework can help you speed things along. Again, Andrew mentioned some of those things, but we're going to continue with that. So first of all, who has worked with aggregations? Excellent. So that means that this will help. This will help you. You'll maybe learn a few more things. If you haven't worked with aggregations, then Karen gave a great overview of what aggregations do, and then hopefully this will whet your appetite to get into some aggregations. So I don't have too much time, right? But we're going to cover a couple of topics. So top and bottom, first and last, sort array, dollar map, dollar reduce. Densification, gap filling, lookup, graphLookup across sharded clusters, and search across sharded clusters. So again, some of the things Andrew talked about, we'll go into a little bit more detail here. So again, let's jump kind of right into it. There's this idea of accumulators. So there's accumulators and new expressions. So these are all components of your aggregation pipeline. Typically, accumulators are going to be found within group and set window fields. And that's going to be our top N, bottom N. And so new expressions then for array operate directly on the array itself. First, last, min, max, and sort array, etc. So let's kick it off with the top N elements in each group. And let's take a quick look at our data set. So what we want to do is we want to show the top 3 highest rated restaurants based on cuisine, right? So a very simple data set that you can see up here is, we've got the cuisine listed, the category that the cuisine is listed in, the name, and then a score based on, how well people think it is. So it's separate data sets, separate documents, separate instances. What we want to look at now is I want to combine some of these, and I want to take the top 3 rated restaurants in each category, right? So I want to be able to do that with the aggregation. And on the left-hand side, you'll see the aggregation code, the aggregation pipeline code. The right side is the output. So what we want to do first is we want to group by cuisine, right? So that's the first stage in our aggregation. Yeah, again, we saw from Karen's talk how the different stages in the pipeline. So our first stage is we want to just group it by cuisine. So that's going to take all the categories, put them separately in cuisine, and now the syntax for top N is, or dollar top N is basically how many do I want? So that's 3, and then I want to be able to sort it in this case descending order because I want the top several to come up first, and then what's my output going to look like? So very simple syntax, very easy to work with, and that's going to give me the top 3 choices or score choices in each cuisine category. And So here's a very simple example that you could actually build in your sample data sets. So some of the sample data sets we provide on Atlas, this is the MFlix data set. So very simply, you could see, okay, I want, based on IMDb rating score, I want to be able to, again, take the highest score of n number of a certain category in my movies, my MFlix. So again, the code is on the left, and this is something you can run and test very simply in Atlas itself, in your data set. So you can see we, again, group on genre, and then we're going to do the top N, and the right side gives us the result. So you could do the same thing with bottom. Obviously, it's going to be bottom N instead of top N, but the same categories for syntax are available. Next now, a different use case, right? A little bit different use case. I want to show the last two bids for items that I'm selling. And again, you can see the data set on the right as the bid amount, the name of it, the idea of the person bidding it, and the timestamp. So some of these now, there's an implicit listing of timestamp. I don't need to necessarily put a sort, descending or ascending it by a sort. I want to be able to leverage the existing timestamp because I want to take the last two bids for each of these. So what is this going to look like? Again, the code on the left, the results on the right. And first of all, we're going to group by, again, we're doing a little group by. So we're going to separate all out the different categories out, or the different bids that were associated on different bid items. And now we want to get the most recent bids, so the very last two, and I only want the last two to provide me with the most recent two bids. And okay, so that's good information. What I want now, let's drill down a little bit on that, right? If I want to, I want to make my results a little more readable. I want a little more analytics on that. So the next step, and you can see on the top, there's the first stage was the group. The second stage now is going to be a sort by, and $sort by or sort array, it allows us to sort the elements within the array. So it's a little bit different than sort because it's operating only on the elements of the array. So the first section, the group by, produces an array of last bids, and now we're going to walk through and actually sort that, the array, and give us the results on the right. And again, and so this would also work with first as well. So last and first, same syntax, top and bottom, talked about also. I want to move into a different topic now as far as map and reduce. So some of you may be familiar with map and reduce capability from in previous, that was in Find. That's been deprecated. So unfortunately, that's been deprecated. But the good news is that functionality is now available in your aggregation pipeline as map and reduce. So they're separate functions. The $map function is going to work on every element in the array and perform that same expression on each element in the array. The reduce is going to do the same thing, but it's only going to return one result as opposed to returning an array. So let's take a look at some of this again. So the map syntax, and again, this is a very simplistic case, but I want to take everything in my array. I've got a character array, and I want to make everything to uppercase, right? So again, it's a very simplistic case, but the syntax here is I'm going to take $map, I'm going to take the input array, and then I'm going to take the expression that I want to perform on that. So it's a to-upper function, and that's going to give us the results. So again, very simplistic, but again, the idea is I can take that expression across every element in the array. So now let's look at the reduce syntax. So $reduce, very similar. It's going to start with the array input, and now it's going to take the expression that I want to evoke on that. And in this case, we're going to concatenate. So I've got an array of different strings, and I want to concatenate all those strings into one string. Again, so I start with an initial value. I've got the values that I'm going to concatenate, or my expression, and then the result. So very simple syntax, but very powerful. You want to operate on an expression on each element in the array and return a single value. Andrew also stole some of my thunder on this one, but this is really cool. So filling the gaps. You want to be able to, like you said, with time series data, if you're getting data and if you're, for whatever reason, you either missed some or there's holes in it, or maybe you're taking every day and you want finer granularity, we can use this paradigm to actually fill in the data. So let's start again with for data collection data from a warehouse. We're checking our inventory, et cetera, and we want to, right now we're only gathering data every other day. And we want finer granularity. We want to be able to see it on a day-to-day basis. So the first thing I'm going to do is add this $densify to it. So in my aggregation pipeline, again, this is one of my stages. I'm just going to do $densify, and this is going to create values on the x-axis. So this is going to create a finer granularity for me as we walk through it. And you have the capability here of, what's the granularity you want. Right now we're looking at day, but there could be hour, minute, second as well. So how much granularity do you want, and the different criteria here. And sure enough, here's our results of filling in the data, and here's an actual picture of it. So we can see the white line, the white hash marks on the bottom is going to be the value that we're adding. Okay, so we added on the x-axis. So now we need to add on the values on the y-axis, right? So we're going to use this $fill. So as you can see, the top gives us the first stage, and then that's kind of grayed out. We're moving to the second stage of our pipeline, which is going to be $fill. And this allows us to fill in the data based on a method that we're going to provide for it. And so so this is going to give us the data. And what I wanted to point out here is the actual methods you can use for interpolation. So the LOCF is the last observation carried forward. So if I've got a lot of different data. I don't want to just put random data in there. So I want to take the last variable, the last value carried forward, and that's the value that I'm going to produce for that. The light green line here, the temperature, that's going to be a linear interpolation. So the method available for you is linear interpolation, and that's going to give you, obviously, the value between the 2 points. The third one is, let's say I want to add a constant value to the missing data. So in this case, I'm adding a 0, but maybe there's a constant value. I want to put it down to a baseline or a steady state, right? So I can add that as one of my functions or methods. So very powerful, very cool. Okay, so lookup and graphLookup across Sharded. So we're MongoDB, right? We don't do joins, right? We do joins, correct. So there are cases, for actually to join data across different collections. I'm sure you've probably run into it, because you can't have one monolithic collection. You want to be able to have sometimes. So there is a need to do a join across these collections. Before 6.0, we would only be able to shard the accounts collection that you can see up here. So accounts could be sharded across different collections, but the transactions collection couldn't be. Now, we can shard both collections across that we're joining. So we can shard accounts and we can shard transactions. No oohs and ahs out of the audience? That's pretty, thank you, I got some help in the front. Actually, no, it is very powerful. So being able to shard, to join across collections, separate collections, and also the same with graphLookup. So let's take a quick, how does this really work, right? So the client sends a request for a query to the Mongo router, MongoS, and then MongoS is going to say, okay, I've got accounts sharded in my 2 different shards. Let's send the query there. And MongoS also says, oh, wait a minute. Ooh, I've got this transactions collections, which is also sharded. So I need to send information to there. The result of the query is going to get sent back, and then MongoS captures all the results and then sends it back to the client. So again, this is very powerful. It's just extending the capability into across sharded collections. So just like you heard Karen talk about search, we can also now take search across sharded collections as well, or across collections. And the big key thing to notice here is there's a sub-pipeline. One of your stages contains a sub-pipeline, and that text search, can now be placed into the pipeline itself, the sub-pipeline. So again, very powerful, very nice way to do it. So yeah, we've outlined there where the sub-pipeline is. Similar with, a quick example, right? But the idea here with dollar lookup, dollar search is being able to combine that dollar search into a sub-pipeline of your lookup phase. So again, we can highlight that, and again, very powerful. Okay, so I want to kind of give you a quick overview of what is available with arrays. So we talked about a couple. We talked about first and last, sort, lookup, sort array. So these are all the dollar functionalities that you can perform on an array itself. Min, max, index of, zip, etc. So now I went through a whole bunch of stuff. So now what does that mean when you're actually putting an application together? So let's put it all together. We're going to use Compass. We're going to use a simplistic example. So I want to take an average review scores of Airbnbs. Again, so the data set that we're working with is one of your samples that come in with Atlas. So you can feel free to use this example and try it out. So again, we've got a length of stay. We've got a score associated with that. But I'm curious now. I want to run some analytics on this. I'm curious, how good is the score based on the same length of stay, right? I don't have that in my straight data. So I've got a bunch of examples of how I stayed and where I stayed, and there's 2 days, 3 days, 5 days. How does that length of stay impact the score, right? So I want to be able to collect this. So, okay, conceptually, let's think about what I need to do first. I need to combine that. I need to combine the different lengths of stays similar to a group by. But that data is embedded or nested into another collection, or a sub-collection. So I got to be able to pull that out. So I have to be able to pull that out, group it, and then I want to be able to get an average score of all the same scores for the same lengths of stay. Okay, so how do we do this? So in Compass, we can take very easily a set union, a dollar set union, which is going to be similar to the length of stay. So what we're going to do now is we're going to take all the length of stays and we're going to group those together, and we do that with the dollar set union. The next step now is going through. We're actually going to filter that data, and we're going to filter it based on that condition of the title of length of stay. So again, these are the steps where we want to be able to group this information. And finally, we want to be able to add our map, a dollar map capability that we talked about. So now we're going to you take the data from score, for which is now on all combined in length of stay, and we're going to take the average score of that, right? So we're going to take the map function to go across. We're going to take the reduce function to give us one score for that value. And as you can see, the result now gives us an average score, a single value, for a list of values that came in an array. So I can now say, okay, here's how score for length of stay are correlated. Again, no oohs and ahs? Come on, guys. This is good stuff. Amazing. All right, so a quick recap, and then that should leave us time for questions. We covered dollar top, dollar bottom. So those are accumulators. We've got the operators that are going to work on the different functions of the arrays, map, reduce. The densification is going to be very powerful for you for time series and lookup, being able to join across shards and then search across different collections. So yeah, any questions at this point? Oh,
Thank you so much. Do we have any questions? I can run around. Perfect. Come into the back.
Hi. So question. Can you talk about how these aggregation operators are able to make use of indexes on the collections themselves, if at all?
Yeah, so absolutely, yes. Everything is going to be taking advantage of the index. The actual how that works, I probably won't be able to answer that right now.
more specific with more specificity, right? For certain types of complex operations, like if you have, for instance, a lookup, for instance, and you wanted to do a join on a different collection, and you wanted to sort that data, from the first collection using an index on the second collection, using obviously a column on that second collection, is MongoDB able to leverage that? Because some of the documentation is not very clear on this.
That is an excellent question, and I think we may need to hit the Ask the Experts, unless Tom wants to jump in here.
So I think the question was, does aggregation pipeline leverage indexes? And the answer is yes. So you would, again, the uses of indexes will, or the reason to use indexes would be to leverage and accelerate many of these sort operations or these stages perhaps in memory rather than doing a full table scan. So absolutely, this could be used to inform your indexing strategy, and of course they leverage, whether you're using a find or using these in stages, would leverage the index to accelerate the performance. And if you had some specific examples, we'd be happy to take a look at those to understand what you might want to index and not index, for example.
Thanks, Tom.
Thank you, Tom. We have time for one more question. Do we have any additional questions in the audience?
All right.
No further questions?
Well, that's good. So
okay.
That means I explained everything clearly. All right. Enjoy the day, guys.
Thank you so much.